Okay, so LED, light emitting diode, it is a semiconductor, and it is also an optoelectronic. And optoelectronics is the study and application of electronic devices that source, detect, and control light. It can be visible light, it can be radiation, any sort of thing like that. And the concept behind the light of the LED is that when it's switched on, the electrons are able to recombine and go into these holes that are created. And in doing so, they release the energy in the form of light. And how they recombine, it's called radiative recombination or spontaneous emission. I learned about this actually in chemistry last year. And it's when an electron is in an excited state, it then drops to a lower grounded state. And in that process, it releases a photon, which is a small packet of energy or light. And this is just a little diagram of the whole concept behind it, because it's kind of confusing. Mind scrolling down, please? A bit about the holes. The holes are created, it's more of a concept used in chemistry and mathematical formulas and theories. It describes the lack of an electron at a position where one could exist in an atom. So, like this example over here, it's of a helium atom, and when an electron leaves that helium atom, right here, it leaves a hole in its place, and this causes the helium atom to become positively charged, and that's basically what the hole is. And then the photons, as I said, are like a quantum or a bundle of energy or light in this instance. And this whole process is referred to as electroluminescence, which is when a material emits light in response to an electric charge passed through it. And the color of the LED corresponds to the energy of the photon, and it's determined by the energy gap, which is the distance between the conductive level and the valence level of an atom. And that, I think, is the basic overview of.
That is a phenomenal basic overview.
Here's a little diagram of the conduction band, and then this is the gap, and this is the valence band.
Very nice. Okay, do you want me to pull the next one up here?
Yeah.
Yeah.
Paul's.
Oh no, not that one. It's labeled LED. It should be at the top.
There we go.
No title.
No title.
Big title. See, title's there.
Right.
So LEDs have been used in a lot of applications. They're starting to really see that their usefulness expands into almost anywhere you need light. LEDs can do the job better than incandescence and fluorescence. And so right here are HD screens that are using LEDs in sports arenas so that you can have HD screens much cheaper than otherwise, and so that the fans can see what's going on better. Then this is the Smithsonian, and in the Smithsonian they used to have mercury vapor light bulbs, and now they're replacing all of those with LED light bulbs, which each LED that they're using can last up to 17 years if they use them 8 hours a day, 7 days a week. And so we can see that even in big places it's starting to be a big change and revolution in light. Keep going down. So I have a short description of it, but Michaelin covered that. So LEDs, they're much more rugged. They can last through much more than an incandescent light bulb. You can drop it pretty often, whereas if you were to drop an incandescent light bulb on your kitchen floor, it would explode. And then I had a definition of a lumen, because that's how they, instead of watts, they use lumens.
Is that down for
Yeah.
Oh, nice.
And then, so a lumen is the equivalent of a watt, except for an LED. And then LEDs, they're kind of similar to a motor in the sense that when they're connected to a battery, energy can flow to the LED, and energy can also flow from the LED into the battery. And so you can use these in a sense that if you were to use a laser that was the specific wavelength of light that the LED would emit, you could then create a current which could then be be used in any number of applications, such as if the police, needed to tell the streetlights, we need to be green because we need to be going where we need to go, then they could easily use an LED sensor at the top of the lights and use a laser to point at that, which would then tell them, okay, we're here. And since it's so specific, they could easily make something that, and as long as they keep it secret, it would be difficult for someone to know what laser to use.
That's great range of application and fantastic description. Really well done. Any questions, guys? These guys? All right. Very nicely done.
Awesome.
Very good.